Solve the system for x and y, use any method. Okay. We really kind of have three methods for solving for x and y. We have graphing, which wouldn't be very successful in this situation because we don't have a graph. We have the equal values method, where we set both equations equal to y or x, and then set them equal to one another. And then we also briefly talked about the elimination method, which I'm going to use right now. Okay, we're going to spend a little bit more time on the elimination method before the year is over. So I'm not going to use equal values method because I'm going to eventually have to divide everything through by 4, which would be okay, but I'm going to end up with a fraction, and I'd have to divide everything through by 16 eventually, and that's going to be really ugly. Okay, so instead, what I want to do is I want to make the coefficients match or be the opposite of one another. So 2 and 5, I can't really make them match easily, but 4 and 16 I can. So I'm going to multiply this equation, everything through, by 4. So this equation becomes 8x. 4 times 4 is 16y. 4 times negative 4 is negative 16. And this equation stays the same, negative 5x minus 16y equals 7. Now, I can add these equations, which will eliminate the y's, 16y and negative 16y. Those are zero pairs. So this is 3x, and this is negative 9. So if I divide by 3, I know that x is negative 3. Okay. Now we're going to take our x value that we found, and we need to plug it into one of the original equations, substitute it. So I'm going to take the equation that was 2x plus 4y equals negative 4, and I'm going to substitute negative 3 in for x. This is negative 6. Okay, I need to solve for y, so I'm going to add 6. 4y equals 2. I've run out of room, but I'm going to divide by 4. And 4 divided by 4 is 1y. 2 divided by 4 is 1/2. So when x is negative 3 and y is 1/2, both of these equations are solved, which therefore means I have solved the system. If I graphed these, they would intersect at negative 3 1/2.